Good morning, students. So we are discussing the numericals on atoms chapter. So yesterday we have discussed few. Let us continue with the numericals. So today's question is: a hydrogen atom initially in the ground level absorbs a photon which excites it to the n is equal to 4 level. Determine the wavelength and frequency of the photon. Okay, so see how to calculate this. They are asking you both, that is the frequency and the wavelength. Yes. So they have given n is equal to 4, that is the fourth orbit. And then next they are asking you about the lambda, and they are asking you about the frequency. Frequency. We know that is En is equal to minus 13.6 divided by n square. This is the expression for energy. Okay. So now if you take n is equal to 1, it will be minus 13.6, but they have given n is equal to 4. So therefore, if I substitute n is equal to 4, E4 is equal to, it is minus 13.6 divided by 4 square. So 4 square is, that is 16. So 13.6 divided by 16, it is nothing but minus 0.85 electron volt. Okay. Suppose if I calculate the change in the energy, delta E is equal to E4 minus E1, that is equal to, so E4 value is minus 0.85 minus of 13.6, because E1 value is how much? It is minus 13.6. So minus into minus, it becomes plus. So minus 0.85 plus 13.6. So if you simplify this, you will get it as 12.75 electron volt. So this is energy, okay, and this is in the electron volt. So convert this into joules in Matira. So that is 12.75 into 1.6 into 10 raised to minus 19. So if you multiply, you will get it in terms of joules. That is 20.4 into 10 raised to minus 19 joules. Yes, copy down till here, students. But namge frequency matte lambda bekagide. So frequency bandre lambda value we can calculate, because why I have calculated energy, because E is equal to, we have h nu. ಹೌದಾ? ಸೊ ಫ್ರೀಕ್ವೆನ್ಸಿ ನ್ಯೂ ಇಸ್ ಈಕ್ವಲ್ ಟು ಏನ್ ಮಾಡ್ಬೋದು, ಇ ಅಪಾನ್ ಎಚ್. ಈ ವ್ಯಾಲ್ಯೂ ನಾವೀಗ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದೀವಿ. ಎಚ್ ಇಸ್ ದಿ ಪ್ಲಾಂಕ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್. ಸೊ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಫ್ರೀಕ್ವೆನ್ಸಿ ಸಿಗತ್ತೆ. ಸೊ ಒನ್ಸ್ ಯು ಗೆಟ್ ದ ಫ್ರೀಕ್ವೆನ್ಸಿ, ಯು ಕ್ಯಾನ್ ಗೋ ಫಾರ್ ಲ್ಯಾಂಬ್ಡಾ ಕ್ಯಾಲ್ಕುಲೇಷನ್. ಲ್ಯಾಂಬ್ಡಾ ಇಸ್ ಈಕ್ವಲ್ ಟು ಸಿ ಡಿವೈಡೆಡ್ ಬೈ ನ್ಯೂ, ರೈಟ್? ಸೊ ಫಸ್ಟ್ ಕಾಪಿ ಡೌನ್ ದ ಎನರ್ಜಿ, ದೆನ್ ಐ ಟೆಲ್ ಯು ದ ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ಸ್. Yes, frequency answer is right. So energy is equal to, we are getting it as 20.4 into 10 raised to minus 19. Hope everyone copied that. Okay. So next, let us see the next part. That is frequency calculation. So frequency is equal to, the formula is what? It is E divided by H. E is equal to what? It is 20.4 into 10 raised to minus 19 divided by the H value, 6.63 into 10 raised to minus 34, which is equal to 3.077 into 10 raised to plus 15 hertz. This is the frequency value. Okay. What about the wavelength? The wavelength is equal to C divided by nu, which is equal to C, the velocity of light in vacuum, that is 3 into 10 raised to 8, divided by frequency, it is 3.077 into 10 to the power of 15, which is equal to, yes. So if you simplify this, you will get it as here, students, that is 0.9744 into 10 raised to minus 7. So wavelength, the unit is what? It is meter. Correct. If I shift the decimal, I can write in angstrom also. It is 974.4 angstrom. Yes, correct. Okay. Copy down the wavelength and the frequency value. We will go for the next question. Yes, completed.
Yes, ma'am.
The next question, students. In the Geiger-Masten experiment, what is the distance of closest approach to the nucleus? That is equal to 79 of 7.7 mega electron volt alpha particle before it comes momentarily to rest, means the final velocity is 0, and reverse its direction. Yes, they are asking you again the distance of closest approach. Yesterday similar question we have solved. So today it is the value of the energy, they have given it as 7.7 mega electron volt. So you can follow the yesterday's steps and you can calculate this. So see how to do this one. Okay. So we need to calculate the value of the R naught here, and the energy value is given as 7.7 mega electron volt, and the Z value is given as 79. So now here the kinetic energy is equal to, the formula is 4 pi epsilon naught Q1 into Q2 divided by R naught. But here instead of Q1, Q2, one is nucleus. So for the nucleus and for the alpha particle, I'll write total, the value is 2 times of ZE, its square. Okay, so this is the combination of alpha particle and the that is for the nucleus. Ninne enittu, yesterday we have seen it was for the proton and the nucleus. So proton matte nucleus iddaga the value of Q1, Q2 will be ZE square. If you want, somewhere you write and keep. So this is for the proton. So today we are writing it for the alpha particle and the nucleus Q1, Q2. So that time it is 2 times of ZE square. This is for the alpha particle. Okay. So now this is divided by R naught, and the values you can substitute. We require R naught here. So therefore the R naught is equal to, that is 9 into 10 raised to 9 into 2 into Z value is 79 into E value. It is 1.6 into 10 to the power of minus 19, its whole square, divided by the kinetic energy. It is given in mega electron volts, so we can convert in joules. That is 7.7 into mega is there, therefore it is 10 raised to 6 into 1.6 into 10 to the power of minus 19. So you can simplify this one and calculate the value of R naught. Yes, 295 into 10 is 2 plus 3. Little check with the power. So if we simplify this, the R naught value is 29.5 into 10 to the power of minus 15 meter. So power you later check it. Okay. Otherwise, you should get it as 295.4 into 10 to the power of, that is minus 16. So 3 antu baralla, just check with the power later. So answer is here, students, that is 29.5 into 10 raised to minus 15 meter, or minus 15 is also called as Fermi. That is 29.5 FM. That is Fermi meter. Okay, you can copy down this. Write the values. We will go for the next question. Yes, here you can see the next question. Which state of the triply ionized beryllium has the same orbital radius as that of the ground state of hydrogen? So beryllium 3 plus they have given. It is in the excited state. Okay. So which state of the triply ionized beryllium has the same orbital radius as that of the ground state of the hydrogen? Yes. So here we can take that is the radius of the nth orbit. Here the nth orbit is the excited beryllium, which is equal to R1 into, that is H. So here that is n value is question mark, n value we have to calculate which state they are asking. So n value we have to calculate. As we know that Rn is proportional to n square divided by z. Rn is proportional to n square divided by z. Right. So now what we can do, we can equate the equation. So what is given? Which state of the triply ionized beryllium has the same orbital radius as that of the ground state? So for the ground state, we have taken it as R1 into H. And for the triply ionized state, it is Rn into beryllium 3 plus. Okay. So for this, now what we can do, that is n square divided by Z. And here it is beryllium 3 plus, which is equal to n square divided by Z for the ground state. Right. So this is n square divided by beryllium. Z value is how much here, students? It is 4, which is equal to. So this is n square is for the hydrogen atom, it is ground state. Therefore, 1 square is 1 divided by 1. So this is nothing but 1. Therefore, n is square is equal to eshtagate. It is n square is equal to 4 and n is equal to 2 and n is equal to 2. Yes. See, is it clear? So which state of the ಅಂದ್ರೆ n ವ್ಯಾಲ್ಯೂ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಾಗಿದೆ. ಅವ್ರು ಏನ್ ಹೇಳ್ತಾ ಇದೆ, ಟ್ರಿಪ್ಲಿ ಅಯನೈಸ್ಡ್ ಬೆರಿಲಿಯಂ is equal to the ground state of the hydrogen ಅಂತ ಹೇಳಿದ್ದಾರೆ. So therefore we have taken it as what, Rn of beryllium is equal to R1 of the hydrogen. Okay. So the formula we know that Rn is directly proportional to n square and inversely proportional to z. So for that reason, if we equate these two, Z value substitute ಮಾಡಿ and for hydrogen ground state ಅಂದ್ರೆ n is equal to 1 ಆಗತ್ತೆ. So simplify, you will get n is equal to 2. Meaning ಏನಾಗತ್ತೆ ಅಂತಂದ್ರೆ hydrogen ದು ground state is equal to, that is the second triply ionized beryllium, right? So that is the meaning of the answer. So copy down this. So this is important question, copy down. Okay. Okay, the next question. Yes, students. Calculate the shortest and the longest wavelength of Lyman series given R is equal to 1.097 into 10 to the power of 7 per meter. Okay, so we need to calculate the longest and the shortest. Both the wavelength we have to calculate. So for that, so already you know how to do that for the longest and for the shortest wavelengths. Yes, yarig gottide, you can continue with the solution. So who don't know, you can observe here. Okay, for the first one, I am doing for the shortest wavelength. So first ನಾನು shortest wavelength ಗೆ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. So for the shortest wavelength, n1 is equal to we have 1 and n2 is equal to we have infinity. n1 is equal to 1, n2 is equal to infinity. So now 1 by lambda is equal to r into bracket 1 divided by n1 square minus 1 divided by n2 square. So which is equal to r into bracket 1 divided by n1 square is 1 square is 1 minus 1 divided by infinity square is just write it as infinity, 1 by infinity is 0. So idenagate, it becomes r by 1. So if you go for, this is 1 by lambda. Hagadre lambda is equal to, in barutte students, lambda is equal to, it is nothing but, it is r. So lambda is equal to, it is r. Yes, r is the Rydberg constant. So therefore we can write the value of the Rydberg constant. No, it will be reciprocal, ala. So now we have 1 by lambda is equal to, it is 1 by lambda is equal to r. So see this, 1 by lambda is equal to, it is r divided by 1. Hagadre lambda is equal to enagatte 1 divided by r agatte, 1 divided by r. So therefore which is equal to 1 divided by, it is 1.0 97 into 10 to the power of 7, which is equal to, so 1 divided by 1.07 is 09 is nothing but what? It is 911.6 into 10 to the power of, after shifting the decimal, I am writing it in terms of 10 raised to minus 10. So ಮೇಲ್ಗಡೆ ಹೋದ್ರೆ 10 raised to minus 7 ಆಗುತ್ತೆ. So after shifting the decimal, I am writing it as what? 10 to the power of minus 10. So 10 to the power of minus 10 is nothing but what? Angstrom. So therefore 911.6 angstrom. 911.6 angstrom. So this is for the shortest wavelength. So for the longest wavelength, what you will do? For the longest wavelength, it is a Lyman series. So therefore N1 is equal to 1 and N2 is equal to, it will be 2. Yes, please do the calculation for the longest wavelength. Shortest I have calculated. Copy down that and calculate for the longest wavelength. So for longest wavelength, N1 is equal to 1 and N2 is equal to, that is 2. Shortest ge N2 is equal to infinity anta baratte. So in one question only we have both the calculation. Hope so now you have the clear idea when you to use N2 is equal to infinity, when to use N2 is equal to 2. Suppose if they are giving you instead of Lyman series, so Lyman badlagi bere yavadadru series idre, like if we have a Balmer series, Passion, P Fern bracket, if any other series are there, it will be different. Okay, so copy down for the shortest wavelength. We can go for the longest wavelength next. Otherwise, you try yourself and tell the answer in the chat box. Yes, shortest wavelength completed, everyone. I'll clear that. I'll go for the longest wavelength calculation now. This for the longest wavelength. See now. That is, we are going to take N1 is equal to 1, N2 is equal to 2. So therefore, it is 1 by lambda is equal to R into bracket 1 by 1 square minus N2 is 2, that is 2 square is 4. It is 1 by 4. So which is equal to, so keep R outside. So this is 4 and 1. LCM is 4. So 4 minus 1 is 3. So it is 3 divided by 4. Yes. So that is nothing but what? 3R divided by 4. Or lambda is equal to, it will be 4 divided by 3R. 3 into R is the Rydberg constant. It is 1.097 into 10 to the power of 7. Okay. So if I simplify this one, I'll get it as 1215 into 10 to the power of minus 10 or 1215 angstrom. Has anybody got the answer? No, it is 1215. Check it once again, or 2155. Yes, other students, what is the answer? Yes, copy down this answer. We will go for the next question. Yes, correct, baby. 1215. Yes, copy down, everyone. Okay, the next question we will discuss now. See the next question. Hope so you are able to see the screen. Yes, whiteboard is visible, no?
No, ma'am.
No. Okay, 1 minute. Kelly. Or yes, now is it visible?
No, ma'am.
No, okay, leave. Go for regular one. Okay, then here only I'll share the questions. Next questions. Wait a minute. Yes. Okay, your next question is, students. Yes. So the question is, the first member of the Balmer series, the first member of the Balmer series of hydrogen atom of the hydrogen atom has wavelength of 6563 angstrom. 6563 angstrom. Calculate the wavelength of the second member. You have to do calculate the wavelength of the second member. Calculate the wavelength of the second member. Copied on the question. I'll tell you how to do this. The question is what? The first member of the Balmer series of hydrogen atom has wavelength of 6563 angstrom. Calculate the wavelength of the second member. Okay, let us see how to do this one. See here. The first member of the Balmer series. So for the first member of the Balmer series, the N1 value will be is equal to 2 and the N2 value will be is equal to 3. N1 is equal to 2, N2 is equal to 3. So that is 1 by lambda is equal to r into bracket 1 by n1 square minus 1 divided by n2 square. Okay. So therefore now 1 by, I'll make it as lambda 1, which is equal to r into bracket 1 divided by n1 square. So n1 square is what? 2 square is 4 minus n2 square. Now 3 square is 9. 1 by 9. 1 by 4 minus 1 by 9. So if I simplify this, it will be 5r divided by 36. This is 1 by lambda 1. Just keep it as equation 1. Okay, this is for the first member. This is for the first member. So for the second member, what you are going to do, see. So for the second member of the Balmer series, it is n1 is equal to 2 and it is n2 is equal to 4. n1 is equal to 2, n2 is equal to 4. Therefore, it is 1 by lambda 2 is equal to r into bracket 1 divided by 2 square is 4 minus 1 divided by 4 square is 16. So 1 by 4 minus 1 by 16. So which is equal to, it becomes 3r divided by 16, that is 1 upon lambda 2. Hagadre, this is equation 2. What they are asking? Calculate the shortest and the longest wavelength of, this one ala question. The first member of the Balmer series of hydrogen atom has the wavelength of 6563 angstrom. Calculate the wavelength of the second member. Andre lambda 2 we require. So what I can do here, students, equation 1 and equation 2, I can divide the equations. So divide equation 1 by 2. What I have to do now? Dividing equation 1 by 2. So 1 ಏನಿದೆ 1 by lambda 1, 2 ಏನಿದೆ 1 by lambda 2. So reciprocal ಮಾಡ್ಕೊಂಡ್ರೆ lambda 2 numerator ಗೆ ಬರುತ್ತೆ, lambda 1 denominator ಬರುತ್ತೆ. So it is lambda 2 by lambda 1 is equal to, what is the values now? Yes. So 1 by lambda 1. So lambda 1 is 5r by 36. ಮತ್ತೆ ಇದೇನಿದೆ lambda 2, it is 3r divided by 16. Therefore 16 divided by 3r. So r will get cancelled. So 16 and 3. So if you simplify this, and lambda 1 value is also given. Okay, so here I'll take. So I require lambda 2. Therefore lambda 1 into 5 into 16 divided by, it is 36 into 3. So these all are there, see. And lambda 1 value you know. So the lambda 1 is given in the question. It is 6563 into 5 into 16 divided by 36 into 3. So you can simplify it further. Just see the question. If any doubt is there in the question, please ask. Yes. So 6563 into 5 into 16 divided by 36 into 3. Yes, correct. Very good, baby. It is 4861 angstrom. 4861 angstrom. Yes, everybody got the answer. Your answer is 4861 angstrom. So after decimal, you may get some values like 0.123, anything is there. So just check. It is 4861 angstrom. Yes, completed everyone?
Yes, ma'am.
Okay. Let us see the next question. The last question for today's class. Monday, we are discussing the next topic, that is the nuclei. Very small lesson again. So the next question, the last question. So see, calculate the longest wavelength. So you have to calculate the longest wavelength. ಯಾವ್ದು series ಕೇಳಿದಾರೆ ನೋಡಿ. For the Lyman series, second one, for the Balmer series, and the third one for the Passion series. So you have to calculate the longest wavelength for the Lyman series, Balmer series, and for the Passion series. So already you know what to do for the longest wavelength here, students. So longest wavelength kedaga here, Lyman series N1 is equal to 1, Lyman Balmer series N1 is equal to 2, Passion series. So Lyman Balmer N1 is equal to what will be for the Passion series? 3 or 4 it is. Bracket P fund, right? Or Passion P fund. P fund is 5. Bracket and Passion, which is 3, which is 4. Yes.
3.
Okay, so for the Passion series, N1 is equal to 3. So for the longest wavelength, what you have to do, that is N2 is equal to N2 is equal to N2 is equal to. So here it is 1 means here 2 will come, 2 means here 3 will come, here 3 means here it is 4. Okay, so like this you have to calculate the longest and the shortest wavelength. Formula already you people know. So previously ನಾವು ಇದ್ರತರ 2-3 question ಅನ್ನ ಮಾಡಿದೀವಿ. So that is 1 by lambda is equal to. So 1 by lambda is equal to r into bracket 1 by n1 square minus 1 by n2 square. So which is equal to r into bracket for the Lyman series 1 upon 1 square minus 1 upon 2 square is 4. So if I simplify for the Lyman series, it is 1215 angstrom. Already ಮಾಡಿದೀವಿ longest wavelength passion Lyman series already complete ಆಗಿದೆ previous question ಅಲ್ಲಿ. So passion ಮತ್ತೆ bracket Balmer and Passion series. Do it students. Yes, Lyman is 1215. What about the other two? So for the Balmer series, what you will be doing, that is 1 by lambda into bracket to r into bracket. 1 by lambda is equal to r into bracket 1 upon 1 square. So that is 1 upon 2 square is 1 upon 4 minus 1 upon 3 square is 9. And for the Passion series, it is 1 by lambda is equal to r into bracket 1 by 3 square is 9 minus 1 by 4 square is 16. So please tell me both the values. Solve it. Then we will end the session. So for the Balmer series, here the LCM will be 36. So simplify. Balmer series and the Passion series. So 2 students go for Passion calculation, 2 students go for Balmer calculation. So that both the answers we will confirm here. Is for which one?
Balmer
Lyman
series.
is, yes. See for Balmer series, I think your answer will be, it is 6563. 6563. Reciprocal and all you just confirm here, students. This is 36. So here it is. Nine za, and here it is 4 za. So here it is 9 minus 4. So 9 minus 4 is how much it is? 5. 5 by 36. That is 5r divided by 36. But we require lambda. So lambda is equal to 36 divided by 5 into r. So therefore lambda is equal to, for the Balmer series, 36 divided by 5 into, it is 1.097 into 10 raised to 7. It is 5.485. 5.485. So here the answer will be for the Balmer series 6.563 into 10 raised to minus 7. So if I shift the decimal, I can write the answer for the Balmer series. Nodi students, for the Balmer series, the answer is, it is 6563 angstrom ಅಲ್ಲಿ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. Okay, 6563 angstrom. So similarly you can do with the this one, that is for the Passion series. So here it is r into bracket. The LCM will be, here the answer will be little bigger one. So 6, Krisha. So 9 and 16 LCM will be 144. Yes. So here 9 16s are. And here it is 16 9s are. So it is 16 minus 9. So 16 minus 9 will be 7. So remaining things I'll just clear it. So now for the Passion series, we have 1 by lambda is equal to r into bracket 144. 16 minus 9. So 16 minus 9 will be 7. So 7r divided by 144. This is 1 by lambda. Hagadre lambda is equal to, it will be 144 divided by 7 into 1.097 into 10 to the power of 7. Yes. So 7 into 1.097 is, it is 7.679 into 10 raised to 7. And here it is 144. So now if I divide 144 divided by 7.679, it is 18752. So 18752 angstrom. This is for the Passion series Z. 18752 angstrom. Yes, copy down for the Passion series here, students. So later, once again, go through all the questions. So we will meet in the next class with the next topic. Copy down this. Happy weekend. Bye, students.